we're continuing in Chapter 5, Section 5. We're learning how to what's called solving right triangles. Right here on number 10, it says solve the triangle. Hint, draw the altitude from y. I want you to understand is we are going to be solving all of the angles and all of the sides of this triangle, which actually, if you think about it, breaks into two right triangles if you draw in the altitude from y. Okay? So we have a triangle here on the left, and we have a triangle here on the right. When I ask you to solve for the triangle, by the way, this symbol right here, that's my angle symbol, right? Angle x, angle y, angle z. Capital letters are angles. All lowercase letters represent sides. Okay? Now, angle x refers to this angle right here, so we're going to call that 30 degrees. Angle y, everybody, goes from here all the way across. All right? And angle z goes right in here. Now, angle z, across from angle z, I'm going to call this side lowercase z. So that's 16 units. All right? And for some reason I can't do it. And 24 represents lowercase x. And y, well, that's the distance from here all the way across. So obviously, of the three sides, y would be our longest side. Now, this is 30 degrees right here, and I made a 90-degree angle here, which is also a 90-degree angle right here. How many degrees is this? This right here would have to be 60 degrees. 30, 60, 90. Did that ring any bells?
Yes.
Okay, 30, 60, 90. So let's call lowercase x a side. X radical 3, 2x. Sometimes you might see this. S. S radical 3, 2s. And these variables just represent the length of the smallest side. Okay? Where is 16? Right here. In this right triangle, right here, the number 16, what does that represent in this right triangle right here? That's the hypotenuse of the triangle. Okay? You can't see that. Let me just kind of draw it for you right here. There's our triangle. I'm saying this is the 60-degree angle. This is the 30-degree angle. This side length is 16. That's our hypotenuse. So if you were to make a little table, and that's not a very good table. I'll erase this part. If you were to make a table right now, our hypotenuse has a side length of 16. 2 times what is 16? 2 times 8. 2 times 8 is 16. It may have been a while since you've looked at the special qualities of a right triangle. There are only 2 special right triangles, a 30, 60, 90, and a 45, 45, 90. Okay? The 8 goes here. The 8 radical 3 goes right there. This is something you should have learned in geometry. Which means this distance from here to here, the altitude is 8. The distance from here to right here, this distance is 8 radical 3. Well, that's the special qualities of a 30, 60, 90. Okay? If I make any 30, 60, 90, Caitlin, that's like just, let's say I make a slightly smaller version than a 30, 60, 90, okay? And I call this side 8. Then this side would be 4, and this side would be 4 radical 3. The special qualities of 30, 60, 90, of every single 30, 60, 90.
So is that 8 and 4 like that? 8 and 4, and then you always do, right? So
That's it. Whatever this side is, this side, whatever the side is across from the 30-degree angle, whatever this number is, you just multiply it by the radical 3, and that gives you the the middle leg, or the side that's across from the 60-degree angle. And the hypotenuse is always double. So if that's a 4, that's an 8. If that's an 8, that's a 16. If that's an 8, that's 8. If that's a 4, that's 4. So, how about this? See if you can fill in this one. Right? I'm going to give you the smallest side. You ready? I'm going to call it happy face. 2 happy faces is correct. Happy face radical 3 is correct. Those are the special qualities of a 30, 60, 90. If I die today, guess what those qualities will be tomorrow? The exact same. They will always be that way, no matter what. All right, 1 second. Let me figure out, before we move on, let's make sure we understand what we have. We have the distance from here to right there. That distance is 8. We have this distance, which is 16. And we have this distance, which is 8 radical 3. Now, does everybody see this triangle right in here? All right, I'm going to move over here. I'm going to make that triangle so that you guys can see things a little bit better.
That's how it's going to be 12.
No. We don't know the angles of this one. That's 24. That's 8. I do need to know this side, right here. What could we use to find the leg of a missing side of a right triangle? Without any angles. We don't know the measure of this angle. And we don't know the measure of this angle.
Pythagorean theorem?
The Pythagorean theorem, yes. We're going to use, let's just call this side lowercase b. We'll call this 24c, and we'll call 8 lowercase a. If I wanted to find what the side length of b is, b squared will equal c squared minus a squared. Whenever you're trying to find the length of a missing leg, you take the hypotenuse squared and you subtract the length of the other leg squared. So we're going to be left with 24 squared minus 8 squared. And if you had a graphing calculator and you plug that whole thing in, you would get the number 512. But b is not equal to 512. b is equal to the square root of 512. Now, you can actually simplify this radical. The factors of 512, everybody, are 256 and 2. And I like the number 256, Adam, because that breaks down perfectly into a 16 and a 16. So if I said the square root of 512 breaks down into a 256 times a radical 2, what is the square root of 256 by itself? 16. This is the simplified version of the square root of 512. So if I wrote square root of 512, this is the decimal equivalent that you get. If I type in 16 radical 2, press enter, do you see how they're the same approximate answer? What I need you to understand, when you guys move on to college and they ask you to keep your answers in simplified form, this is the most simplified that you can get. Okay? So what I want you to understand, go back, right here, for this distance, the leg, right here, that is 16 radical 2. So right here you can put 16 radical 2. I'm going to highlight some things. Hopefully this will make sense to you. I want you to understand that the distance from here to right there is 16 radical 2. And the distance from here to here is 8 radical 3. The distance all the way across is 8 radical 3 plus 16 radical 2. That's the exact distance. But you can type that in the graphing calculator and give me the approximate value of that distance. So you can say 8 radical 3 plus, I'm just going to go up and grab it, 16 radical 2, press enter, 36.48 is rounded to a 36.5 is fine. 36.5 units. That is your distance of y. I want you to understand that y is the whole thing, everybody, from here all the way across. Now, we're going to use a little trigonometry to find out the measure of this angle right in here. Now, this angle right here is very important because that's the measure of this angle right in here. I want you to understand that angle y is going to be 60 degrees plus whatever we get for this angle. Let's look at this triangle right here. So that you guys are just focusing on two things. I want you to focus on this side being 8 and this side being 24. And we're going to focus in on just that angle right there. Just this angle. I need to find the measure of it. And then we're just going to add 60 degrees to it to find angle y. Now, if I draw an arrow going across, right there, that would mean this side is the opposite side. This is my hypotenuse, and this is my adjacent side. Which two sides do we have? We have the adjacent side, and we have the hypotenuse. Yes, we do have the opposite side. We called it 16 radical 2, but right now let's just use the 8 and the 24. Okay? Which trig ratio deals with the adjacent side and the hypotenuse? Cosine. Adjacent hypotenuse. So write this down. The cosine of theta, we're going to call this measure of this angle theta, is equal to the adjacent side, 8, over the hypotenuse, which is 24. Theta is going to equal the inverse of cosine of 8 over 24. So all you have to do in the calculator is hit second cosine and just do the fraction 8 divided by 24, which is the same as a third. You can use 1/3 and it still work. So you're 70.5 degrees. You might be, your mode, if you hit the mode button, you might not be in degree mode. You have to be in degree mode for this to work. If you're not in degree mode, you'll get the wrong answer. Now add, see 8 over 24, that reduces to what fraction? 1 over 3. Second cosine, if you would reduce the fraction, guess what? Same thing. Okay? So what's the measure of our angle? 70.5 degrees, which means this angle right in here is 70.5 degrees. Huh. So if this angle is 60 degrees, and this angle is 70.5 degrees, what is the whole measure of angle y? 60 plus 70.5 degrees, which is 130.5 degrees. Now, how many degrees are always in a triangle, everybody? When I say triangle, you say 180. Triangle. Wow, very enthusiastic. So what can I do with the 130.5 degrees? 30 degrees. Take it away from 180. What's that give us? I think it's 19.5 degrees. By the way, all of these right here are your final answers. All of these add up to what? 180 degrees. And these are the lengths right here. These are the lengths of all of your sides. Solving a triangle asks you to find all 3 angles and all 3 sides. That's what solving a triangle asks you to do. You all have a fabulous